Hello everybody, welcome back. It's me, Justin. Today we're going to be doing Lab G, which is mainly going to use our favorite program, Mathematica. I haven't talked about it too much in the lab, however, we have used it quite frequently, so let's just get to our actual procedure and what we're going to be doing today. So basically what this lab entails is manipulating the Lorentz force, as you can see here. What we're actually going to be doing is we're going to be manipulating different variables and testing how it affects the path of a moving charge and plotting it, which is the entirety of the lab basically, and I'm going to show you how to do that today in Mathematica. So we're actually making a couple assumptions before we do that, mainly that the magnetic field's only going in the z direction, and that the charged particle is only going to be confined to the x and y axes. For task 1 in particular, we were supposed to derive these four equations, which I'll go over in more detail in class. However, they will be quite useful just to observe the situation, but let's get into actual coding now. So the main line of code we're going to be using today is going to be this particular equation, which is given to us in the lab manual conveniently. So what we end up doing is we're quite literally changing values and variables in order to see how it affects the motion of a charged particle on a plot. So we're using this and then modifying it and then plotting it to see what it does. So basically then we go to Mathematica and I set BZ equal to 1, as you can see, and then I have our code copy and pasted for task 2 and for actually the rest of the lab, since we're just using this as a base code to modify. But when we run it, we should get 4 interpolating functions for x, y, vx, and vy, but those aren't really relevant as long as we're not getting any errors, so I just put a semicolon after the code so it doesn't show. And then we do a plot to evaluate it. For task 2, it should look like this, and then it should just give you some sort of plot that looks like this with 2 different functions, nothing too crazy. But then we move on to task 3, and for the rest of the tasks we're basically combining task 2 and 3 while modifying the code. But for task 3, the code for the parametric plot is given to us to modify, but for task 3 we originally don't modify it, so if we run it we get a parametric plot of what's going on, and for this one it's a circle, which tells us the motion of the particle. In this case is a circle. And that's pretty much all of the lab, so good luck and thank you.